Let's get started. So today is the last day of Task 2 content. So just a reminder, each week is the content for the task that'll be due, well, kind of the following week. And then next week, I keep getting questions about this, but now it's time to just talk about it head on. Next week, there will be no lectures. I'll be holding extra office hours in my office during lecture time. I have this lecture and a 116 lecture right before this as well. So I'll be in my office for 2 hours, Monday, Wednesday, Friday next week from 1 to 3 for extra office hours. And I know y'all can make this time, so if you want to come see me and talk about 116 stuff, or anything, I suppose, come see me in the extra office hours. There will be no lecture, no lab, and I treat this as a complete void in my schedule when I map out the semester, which means the deadlines that would be next Wednesday are pushed back 1 week. So the Task 1 deadline is pushed back a week. The Task 2 expected deadline pushed back a week. So it's effectively just a black hole in the 116 schedule that doesn't exist. Next week, 116 just doesn't exist, except for office hours. The reason I do this, first of all, I call this my fake fall break, is my name for it. We don't have a fall break like we do in the spring, where we have a 1 week break right in the middle of the semester. Like the spring semester really is perfect with that. It's so nice. Fall, we don't get that. So at least in my courses where I have control over everything, I'm going to add that break and make that right. Give you a 1 week break right in the middle of the semester. Now, I know a lot of you will use that to catch up on things. You'll use it for other classes. This is about the time when a lot of other classes are having midterms. So I know it won't be a full break, but at least 116 is going to back off of you for a week. Since I treat this as a void in the schedule, if you just don't even think about 116 for a whole week, I'm not going to hold that against you. If you do, especially if you're catching up, it's probably not the worst idea. But if you don't even think about 116 for a week, focus on your other stuff. But what I do ask, like pretty please or whatever, try to at least take one of these days, probably on the weekends, and just chill. Just turn off your brain. Try to not get stressed out. The reason why I like that spring break so much is it's great for our mental health. By the time in the fall semester when we get like right before the fall break, the actual fall break right before Thanksgiving, we're all, myself included, the TAs, all of you, we're all so burnt out by that time, and it's just not good for us. So at least try to take one day and just focus on your mental health, chill, do something fun, and do whatever, or just sleep for a whole day would be a good idea too. But just try to chill at least one day. Don't spend that whole time just focusing on other courses and midterms and all that. Try to actually take a break somewhere in there. I know it's hard when it's just one class that's backing off, but at least try to take a break somewhere in there. Okay, let's talk about polymorphism. I don't know. Well, I do know. I have so many copies of every slide deck on my desk or on my laptop, so I download it for every lecture. I do that so just to be very clear that I'm using the same slides for lecture that you have access to. If you're ever wondering why I always re-download the slides, I want to make it 100% clear I'm using slides that you have access to. I've had a lot of lectures where the professor was out of sync and what was online was a different slide deck than what they were presenting, and I didn't like that, so I don't do that. So we saw this chart a couple times. We saw this all week. I think I showed it in all 3 lectures this week. I want to add one extra clarification to this. I said this is the type hierarchy. All these arrows means extends. So like byte extends any val extends any. And anything that extends any val goes on the stack, and anything that extends any ref goes on the heap, and we only work with references to those objects. I oversimplify a little bit that you can have variables that extend any val that will go on the heap if they're state variables of an object that's already on the heap. We saw that in the memory diagrams, but I want to make sure that's clear on this slide as well. If they're part of an object, if they're a state variable to an object, any vals are going on the heap. But what I mean is the value themselves. Like if I store a double in any variable, it's the actual value for that double. The 64 bits for that double, that's what's being stored in that variable. Anything that extends any ref, any variables of these types, what's being stored is a reference to an object on the heap for that variable. But if you're anything that extends any val, if you're in a stack frame declaring a local variable or a parameter, those are always going on the stack. The only way they can get on the heap is as a state variable as part of an object that's already on the heap. All of our classes extend any ref. If we don't extend anything explicitly, then we implicitly extend any ref. Scala will add that for us. So if we have this class, physics object, and we don't extend anything, Scala is going to say, hey, you didn't extend anything, you're extending any ref. You have to. So if we don't explicitly extend anything, we extend any ref. So this is the same exact thing as saying extends any ref. This code, these two objects, these two class definitions will do exactly the same thing. In the second one, we're just making it explicit that we extend any ref. Generally, we don't do this. We just leave the implication there and trust that everybody reading the code understands that this extends any ref. But there's no harm if you do want to add that and be extra explicit that this extends any ref. Every class that you have will eventually extend any ref. So you can have a class that extends a class, that extends a class, that extends a class. Eventually, you're going to get to a point where you write a class that doesn't explicitly extend anything, and that's going to extend any ref. So let me pick on my health potion example again. It's the example of the week. We have health potion, which directly extends game object. Game object directly extends physics object. Physics object doesn't explicitly extend anything, so it implicitly extends any ref, and any ref extends any. So health potion either directly extends game object, and indirectly extends physics object, any ref, and any. So health potion ends up with the state and behavior, inherits state and behavior from 5 different classes. 5 different classes. So if we want to find out everything that a health potion can do, all of its state and behavior, every piece of state and behavior in health potion, we can look through these 5 classes, the 3 classes that we have on the screen, and 2 classes inside Scala itself. We can dig through Scala source code and find out what the other 2 do and figure out everything that a health potion can do, all the state and behavior from these 5 classes. We call this an is-a relationship. I'm not too big on vocab, but this one I think is really explains what the concept is quite well, the is-a relationship. So in a very real sense, if something inherits from another object, another class, it is that class in a very real sense. So a health potion, of course, is a health potion, but a health potion is a game object. A health potion is a physics object. A health potion is an any ref, and a health potion is an any. This is a similar relationship to how like a square is a rectangle, a square is a quadrilateral, a square is a shape, and a square has all of the properties from all of those things. If we say this is what the properties of a rectangle, it has 4 right angles and 4 sides. Well, a square inherits that property from rectangle, inherits properties from quadrilaterals, inherits all that stuff. Very similar thing here. Health potion is a game object, physics object, any ref, and any, and it can be treated as any of those types. And this is where polymorphism is going to come in. In my opinion, polymorphism is the big payoff for inheritance. Inheritance has some benefits on its own, but polymorphism is the big one. Once we have inheritance, and this is a relationship which comes from inheritance, we can use polymorphism, which means if an object is a certain type, it can be stored in variables of that type. This is what polymorphism is. Man, I never trip up on that word. And the distinction is important. What's the difference between inheritance and polymorphism? A lot of students tend to bundle them into one big OOP bucket in their brains, and then when they're asked on the interview, what's polymorphism, and they explain what inheritance is, what's inheritance, and they explain polymorphism. This is the difference right here. Polymorphism, we can't use unless we have inheritance, because inheritance is that is-a relationship. If we don't have an is-a relationship, we can't use polymorphism. But polymorphism is when we have an object of one type and we store it in a variable of a different type. At that moment, that's when you're leveraging polymorphism. So let's see what this even means and what it is. Polymorphism, poly, many, morph, form, polymorphism, many forms. So the health potion can have many forms, in this case 5 different forms that it can act as in our code. Which means we can store health potion in variables of any of these types. So we can have a variable of type any ref, physics object, game object, or health potion, and store objects of type health potion in any one of those. This is all valid code. And we're starting to break down the walls of a restriction that I told you about. Week 1, Scala, it's strongly typed. You have a variable of one type, it can only store that type. If you have a variable type int, you can't put a double or a string in there. It can only store an int. We're going to start breaking that down a little bit now that we're learning polymorphism. We can get values of one type in variables of another type as long as the object type inherits from that variable type. So health potion, the object type, I'm creating a new object of type health potion. I'm getting a reference to a health potion. Since health potion extends game object, it's in its type hierarchy, I can store that reference to a health potion in a variable of type game object. And it's a valid assignment. Do that all day. And that's what polymorphism is. That's it. If we're taking an object of one type and storing it in a variable of one of its supertypes, that's it. Polymorphism. I shouldn't say that's it, because there's a lot to it. But that is what polymorphism is. TA sits down in your interview a few weeks from now and says, what's polymorphism? Oh yeah, it's when we take an object of one type and store it in a variable of another type. Then the TA is going to have some follow-up questions for you, of course, because they're going to be like, you just memorized that because Jesse said it in lecture. And then they're going to ask you some follow-up questions like, can you store an object in a variable of any type? And then you talk about inheritance, and no, it's got to extend it, it's got to inherit from it. You talk about all that stuff. But this is polymorphism. When you're asked about polymorphism, it's all about storing objects of one type and variables of one of its supertypes, and variables of another type, following the is-a relationship, which is inheritance. Does slide 9 mean health potion is the base class? Health potion would be the concrete class. I'm trying to think. I haven't used the term base class, but I'm trying to remember if that is if that's terminology that's used somewhere. I don't remember if it is. Superclass would be, health potion would be the concrete class. Health potion has superclasses of game object, physics object, any ref, and any. These are all superclasses of the health potion class. So anything up a class's inheritance tree would be its superclasses. That's not really true. Most of these are abstract classes. These could all be abstract classes, and then health potion would be the concrete class, the one we can actually create instances of. I think the way I wrote the code for physics object, I guess we can check. No, I did make it abstract. So I can't create an object of type any ref, physics object, or game object, but I can create a health potion because it's not abstract. So health potion would also be a concrete class. For better or worse, there's a lot of vocab with these types of topics. So what? So we can store objects of one type and variables of another type. Why do we care? Well, I'm going to start out with a downside. This is actually pretty restricting, storing variables of one type and storing objects of one type and variables of another type. We actually have a pretty big restriction here. I'm going to start with the downside because I'm not trying to sell polymorphism, right? I'm going to try to make it sound awful. So we can only access the state and behavior based on the variable type. So if we store a health potion in a variable of type physics object, we can only access state and behavior known to the physics object class. That includes everything defined in the physics object class and everything it inherited from any ref and everything it inherited from any. That's what we can access through the variable of type physics object. But physics object doesn't know anything about game object. Nowhere in the physics object code do we mention game objects. We don't say, hey, physics object, by the way, there's a class out there called game object that's extending you. We don't put that code in physics object. Physics object has no idea. It knows about any ref, so we can go, hey, any ref, have you heard of a game object? No. Hey, any, have you heard of a game object? No. They don't know about this class. That code doesn't know about this class. So this variable of type physics object does not know about game object or health potion. Now, game object knows about physics object, but physics object doesn't know that these other classes are out there. It doesn't know it's being extended by other classes. Yeah? So it really just only goes. Yes. Yep. Like the any class doesn't know like this whole world out here exists. The any class doesn't know anything. Oh, by the way, I think I forgot to mention this before. I won't do this too much, but those of you who do have Java experience, any would be like object. Actually, I think any ref would be like the object class. And you say everything extends object. Then any val would be your primitives. If you're not familiar with Java, just ignore that sentence. So this object mass method is defined in the game object class. So if I want to access that method from a variable, that variable type has to know about the game object class. So from potion 4 of type game object, perfectly fine. We can call object mass. From health potion, the type also knows about object mass because it inherited that method, the abstract method from game object, and then gave it an implementation. So that's perfectly valid, and we've done that. We've been doing that for days, is creating health potions and dodgeballs and calling these methods. We can do that all day, too. But once we go down to physics object, since object mass was defined in the game object class, once we have a variable of type physics object, this doesn't compile, everything breaks, not allowed to do this. Even though potion 3 stores a reference to an object that does in fact have an object mass method. Like that functionality is sitting there ready to be called, but we can't call it from a variable of a type that doesn't know about that functionality. So it's a pretty big restriction of polymorphism. That's why we don't just create all our variables of type any. Like we could just have variables that basically don't have typing and treat this like JavaScript by creating every variable of type any. Problem is we lose all of our state and behavior. We lose access to it all. We wouldn't have access to any state and behavior defined in these other 4 classes. So it's very limiting to do that. So we generally like to use the types lower down the type hierarchy, closer to our concrete objects. So still begs the question of why polymorphism. So let's get into the benefits. And polymorphism is a quite powerful concept. We're going to see some good benefits here. So let's revisit our player class. And we had these 2 methods, use ball, use health potion. And we noticed that these methods do very similar things. The bodies of these methods are almost identical, just the variable names are different. When I use an item, I'm just going to defer to that item, call its use method, pass it a reference to the player that's using that item, and let that item do its thing. Now, this ain't too bad. I got 2 items in my game. But what happens when we expand this? What happens when we do have 100 items, 100 different item types? What happens when I want to add even the 3rd item type? I got to add that item, create the item. If we're not using inheritance and not extending game object, I have to rewrite all the methods in all my other items. And then even with inheritance, I'm going over to the player class and adding a new method. I'm just going to cut and paste one of these two methods, change the types, change the method name. Not the biggest deal, I guess. But once I have 100 of those in this class, which doesn't really do all that much, there's not much functionality here. Once I have 100 items in my game, this class is going to be like 400 lines long. If I have the same styling here, 4 lines per method, I'm going to have 400 plus lines of code to have a class that doesn't do all that much. It just defers functionality to other classes. Doesn't do that much. Moreover, when I'm somewhere else in my code, somewhere in my inventory logic or wherever, where I'm actually using the items, I have to have this big if statement or a switch match statement that's going to say, okay, I'm using an item. The player just said, use this item at inventory slot 4. And it's got to say, if it's a dodgeball, call use dodgeball. If it's a health potion, call use health potion. If it's a bow and arrow, call use bow and arrow. If it's a sword, call swing sword. And we got to go through all this logic. So multiple places in our code, we'll have to have blocks of code like this where we have basically cut and paste code for every object type that we have. This is tedious. It's extra work that we don't want to do, first of all, but it also makes it easier to introduce bugs. Like if I have nice, small, simple code, it's easier to maintain. I can look at this class and spot a bug pretty quick if one exists. But if it's 400 lines of code and I'm scrolling trying to find the typo, that's going to be painful. It's going to be tough to change. It's going to be tough to maintain that code. It's going to be tough to track down that bug that I have, that some player reported that their sword didn't swing properly. It's going to be tough to do that, especially when I have big blocks of code like that, 400 lines of code in multiple places in my project. Bad stuff. Let's fix that. So instead of having a method for each type of game object, I'm just going to make one method, use item, that takes a game object. One method that works for everything that extends game object. So every game object in my code, I create a new object type, I extend game object, this method works for that type. Types we haven't even dreamed up yet, this method works for them. As long as they extend game object, everything's fine. When we want to call the method, we have different types of items in our inventory. We just call use item on a dodgeball, use item on a health potion. And here's where we see where we're making that assignment, storing types of one type in a variable of another type. Usually the way we saw it the first time, we wouldn't just declare, if we're creating a health potion, we're going to store it in a variable of type health potion. Why would we do anything else? But here's where we do want that feature, is when the assignment is happening across a method call. This method has a parameter of type game object, but I can call it with a dodgeball or a health potion. The same method, I define the method once, but when I call the method and I have this implicit assignment of parameter item of type game object equals argument potion, that assignment is assigning a health potion to a game object variable, and I can write one method that's coded to the abstract type that can work for any of the concrete types that extend it, either directly or indirectly. If I want different types of health potions, I can extend health potion 8 times, and all those will still work in this method. And I can do this, and then I'm going to call the use method and pass it a reference to this player. I can do this because the use method is defined in the game object class. So when we first did this, when we first saw these abstract methods, you probably should have been asking yourself, like, why? Why even do that? Why would we create the abstract method that does nothing and then override it in our health potion and dodgeball classes? Like, why not just have those methods exist in dodgeball and health potion? What's the point of that abstract method? This is the point. This is the reason why we create that in the abstract class. Because even though this use method doesn't have a definition in game object, what it does is guarantee that everything that extends game object will have a definition for that method. It will have a method named use that takes a reference to a player object and returns unit. Guarantees it. And when we extended this class, we had to fulfill that promise. We had to fulfill that guarantee and implement that method before we were able to create instances of health potions and dodgeballs. We had to implement this method in these two classes to fulfill that guarantee. So now when I have a reference to an object of type GameObject, I can only access GameObject specific functionality, or functionality that the GameObject type understands, but the GameObject type understands object mass and use. So from variables of type GameObject, I can call these two methods because it's guaranteed that everything of type GameObject will have implementations of those two methods. That's the reason why we create abstract methods. So we have that guarantee. If we only define these in dodgeball and health potion, I can't write this method. Because once we call use, well, use isn't known to the GameObject class, so we can't do it. But since we created it as an abstract method here, perfectly valid. And now when we're testing, we don't have 400 lines of potential typos to look through. I have 100 items in my game. I'm expanding. I'm building new features, building this whole game out. That player class doesn't change. 100 items in my code, I still have roughly 10 lines of code for player. I don't have to expand that. I test the player class one time, and it's going to work no matter how many items I expand to. That method in my inventory that uses items, well, that's just player.useItem. All that code squashed into one line, a couple lines maybe. Test it once, make sure it called useItem. Done. Much more difficult to write bugs in this program when we're leveraging polymorphism like this. Oh, Discord, where are you? Okay, any questions on that so far? Yeah. Mm. So that's a requirement for polymorphism. So the question, like, why do we have the abstract class? So when I introduced inheritance, I said it's a way to factor out common behavior, because without talking about polymorphism right away, that's my big selling point, is factoring out the common behavior. But once we have inheritance set up, that enables us to use polymorphism. So say we didn't use inheritance at all, we have health potion extends any ref, GameObject implicitly extends any ref, or health potion and dodgeball, without the GameObject or physics object. Then I can't do this trick anymore. I could take an any ref or an any, but those classes don't know about the use method that takes a reference to a player. So I wouldn't be able to do this, and I would have to have separate methods for every type in my game. The fact that I used inheritance and created this abstract GameObject class and then extended it through health potion and dodgeball, that's what's enabling me to do this. So inheritance is a prerequisite for polymorphism. Once we set up inheritance, we can use polymorphism. Did that get to your question? So the advantage here is that this can take as a parameter anything, yeah, as long as GameObject is in that object type's inheritance type hierarchy, this method will work for it. Now I can't do any specific things specific to dodgeball or health potion. Like I can't access the volume of a health potion in here because I have a variable of type GameObject. But anything defined in GameObject, I can get its XY location. I can call object mass and use. I can access its, where do I have it? I can access the physics object XY state variables. I can access all that. I can call toString on it because that's from any. But I can't do any health potion or dodgeball specific things here. So it is a trade-off. But if we have one method that we want to use for any game object, as long as we stick with the game object stuff. And then typically when we're coding, if there's something, I'll code like this to the abstract class. And then if there's something I'm missing, like, oh man, I really want to call this method from health potion, but I have a reference to a game object because my method is generic for a game object, for any game object. If I'm in a situation like that, I'm going to move that functionality to game object as long as it makes sense to do so. I'm going to move that functionality to game object and then just have every game object inherit that behavior and then start using that behavior. So anything I want to use in these generic methods, I got to move that functionality to game object and say every game object will have this state and behavior. Isn't it? I know. And this is like the big payoff of inheritance. Like inheritance on its own, it's not too exciting, but this is the payoff. Which, if you don't appreciate it as much as we are right now, you'll get there, baby. You'll get there. Yeah, question? So I do understand. Yeah. This method call right here. So this is defined as an abstract method in GameObject. So when I have a reference variable of type GameObject, I can call that use method because GameObject has a contract here. It says, I guarantee everything that extends me, so anything that is a type GameObject has to have a use method that takes a reference to a player. So we can safely call, we have a reference to a GameObject, we can safely call use and give it a reference to a player, and we know that that method will exist. We don't know what it's going to do. I might be drinking a health potion, I might be throwing a dodgeball, I might be swinging a sword. I don't know what it's going to do, but I know that method will exist and it will have some functionality. Or I guess it could just be an empty method too. It doesn't have to have meaningful functionality, but I know that method's going to exist. So this is the first key point in polymorphism. I can have objects of one type stored in variables of another type, and where it really becomes useful is when we make that assignment across a method call. When we have different types hanging out in the heap, I got a whole bunch of different types, and I want to call a method that works with one of the types that those objects are. That sentence came out weird. But I want to call a method that takes as a parameter one of the types that my objects inherit from. And I can do that because dodgeball and health potion both inherit game object. I can call that method with either type. Just like println takes a reference to not necessarily a reference, but as its parameter takes an any. Like the type is any, so we can literally print anything to the screen. And then it'll call toString, which is defined in the any class. So absolutely everything has a toString. Absolutely everything can be printed to the screen. And that's why, because println takes any as its parameter. Absolutely anything can be printed to the screen. Might not get meaningful information, but it's allowed. All right, so let's build up to the next big payoff. We got two big payoffs for polymorphism today. I guess really that is the two big payoffs for polymorphism. Is let's make our player a game object. This is something we can do. So I'm going to extend game object for our x and y. And since I'm extending game object, I have to implement the two abstract methods. Object mass, I'm just going to pick some implementation for that. Use, if a player uses another player, I decided to call that a melee attack. And decrease their health based on the strength of the attacking player. I needed an implementation, that's what I chose. So now our player is also a game object, which means our player is also a physics object. And this is where we can start playing with some more physics. So our physics object, if we had that assignment, if we were running that assignment again this semester, if we had this physics engine, which had a method do physics, it didn't on the assignment, but I just called it that for the slides, do physics, which is going to take a list of physics objects. When we write our physics engine, we don't want to be thinking about health potions and dodgeballs and players and how an arrow is going to arc through our game. We don't want to think about all of those individual objects. We're just going to mess around with physics objects. So when you write physics object, when you write physics engine, when students did write physics engine, it would be write a method that takes a list of physics objects and applies physics to them. And you would have the location. We only have location in these examples, but you'd have location, velocity, and the bounding box for each object. And you would take the velocity, update the location, apply gravity, so things are going in nice parabolas, and look at the bounding boxes and detect collisions between these objects. We do all these things, and physics objects would have that location, velocity, and bounding boxes would have that information. The bounding box, if you haven't heard that term, just like how much space it takes up in the world, and everything had to be, I forget the word, rectangular prisms, technically, had to be orthogonal to the axes. So we would have all that defined in physics object, and your physics engine would just mess around with physics objects. It has a whole bunch of physics objects. It didn't care about anything else. And then our game code worries about health potions, dodgeballs, and how they should interact with each other. So we need to give all those objects to our physics engine, but since they're all physics objects, the next big payoff for polymorphism is that we can store values in data structures as long as the type of the data structure is relationships for each object. So our player, now that it extends game object, which extends physics object, is a physics object. Health potion is a physics object. Dodgeball is a physics object. So if I have a list of physics objects, I can mix all these types in that same list, send that list of physics objects over to my physics engine, and have all of their physics applied to them. And then I'll tell the physics engine, I'll call do physics 60 times per second. I got a 60 FPS game with nice smooth physics, and things are moving around in my game world, and I'm happy with that. But the physics engine doesn't care about any of the game logic code, and the game logic code doesn't care about any of the physics code. And this is something that I don't call by name enough, but this is encapsulation. This is the idea where we're separating our code. We write our physics engine over here, we test it, we make sure it's good, and it works with physics objects and physics objects only, and it's its own thing. Then we build our game over here. We say, okay, I'm going to have dodgeballs I'm throwing around, and I can drink health potions, and I can move around this world. I write all this code over here. I'm going to use that physics engine by just calling one method and saying, hey, do your thing. I get my objects back. Well, I don't even get them back because it's all by reference. That's going to update all my objects in the heap, update their states, and I just have physics. But I don't have to mix the physics engine code with my game logic code. I'm going to have it completely separated, completely encapsulated in its own module that I can just call those methods. This is a very powerful idea in programming. This is something, if you're not getting in the habit of yet, you definitely should. Instead of having all of your code in like one big main method, which is how we all start out programming, you write everything in one big main method, you have a mess, and every part of your project is just intermingled with all of the other parts of your project. We want to start separating that. I want my physics engine over there. I want my game logic over here. I want my player to not have to know about every game object, every type of game object. I'm going to use polymorphism for that. I'm going to make sure that each piece of code I write, I can write as isolated as possible, test it, and then just have it communicate with my other modules and start building a larger project where I'm not mixing my code together too much, and I'm separating them as much as I can. But the takeaway for polymorphism right now, I have a list of physics object. I can store any type that extends physics object in that list. Is it allowed to have a class extend game object to not override the use method? Have a class inherit game object, but don't want to use the method. So if you inherit game object, you have an obligation to implement use. You have to override use and give a definition for it. But you don't have to right away. So you can extend game object and not implement use, but that class will have to be abstract as well. So you can have an abstract class that extends another abstract class and then say, okay, whoever extends me has to implement use. But eventually, by the time you get to a concrete class that you can actually say new whatever, that whatever has to have a definition for use somewhere in its type hierarchy. You can't have a new type, a new object of a type that has an abstract method. You have to implement them all before you create objects of that type. Oops. Okay, let's talk 43. Crap. We can do this. So let's talk project. Each Friday, I like to give tests for the task that we just finished learning the content for. So task 2, if you haven't started it yet, just a very brief introduction to it. You're going to create an abstract method, an abstract class modifier with 2 abstract methods, update price and compute tax, and 3 concrete classes, sales, sales tax, and bottle deposit, all that extend modifier. And then update the item class with an add modifier to add a modifier to that specific item. Update the price method, so instead of just returning the base price, you're going to return the price with the modifiers applied. I get a lot of questions on the wording of that one that I want to clarify. And the tax, which should return the tax with all the modifiers applied. So when you add a modifier, say I create an item and give it a sales tax of 4% and a sales tax of 5%, and my item's base price is 100. When I call tax, I should get $9 from that. That should return 9. So those modifiers, when I add modifier, those 2 taxes, tax should return a value with those taxes applied to the base price, or to the sale price actually. And price, same thing. If I have 2 sales, and I'm going to code up this test case right here, if I have 2 sales added to my item, then those sales should be reflected in the price of that item. Let's do this. So we have some code for task 1 that we did last time. And personally, I never start my test cases from scratch or my test suites from scratch. So if you want to, fine. But I'm just going to cut and paste. Delete all my old code. Test modifier. Actually, I'm just testing sales. And I have some classes started here. I didn't implement them, but I just have the methods that should exist created but stubbed out. They don't do anything, but just so I don't get compiler errors when I write my test. So to test this, I need an item. I'm going to create an item of type item equals new item. Testing, let's just get something on here, 100, so the math is easy. Well, actually 100 because that's what my test case is that I'm coding up. I'm going to need a couple sales. Sale 1 of type sale equals new sale. And this is going to be a 20% sale, 20.0. And for my imports, we're going to have quite a few classes in our items package. So we could import all of them individually, or my items package, I'm just going to import everything. Now we don't have to worry about importing each thing individually. That underscore says import everything from this package. I'm going to create another sale, sale 2, and just to be cute about it, I'm going to store this in a variable of type modifier. This is perfectly legal if I spell it right. create a new sale, and this will be my 10% sale. 0.0. This will be my 10% sale for the item. Now I have a few methods I can call on this item. One, I want to add my modifiers. I'm going to add my sale 1. I'm going to add my sale 2. The add modifier method takes a modifier as a parameter. So whether I have a sale stored in a variable type modifier, a sales tax, a bottle deposit, doesn't matter what I have. I can add it to my item because add modifier takes a modifier. As long as I'm adding something that extends the modifier class, it's perfectly valid, perfectly legal method calls. And then I'm going to have multiple modifiers in my items, but if somewhere, maybe I have a list of modifiers, I can store sales, sales tax, bottle deposit. I can store all those things in a single data structure, which is probably how we want to handle that one, right? And then we have a few methods that we can call that we need to test: price and tax. Oh crap. We only have a minute left, so I was trying to get to the code from the previous lecture. But I'll comment it here. So price, I wrote a compares double method. If you haven't done this yet, if you haven't been doing this, I recommend writing a method that'll take 2 doubles and return a Boolean to do your epsilon stuff. So that would be the next thing I do. But we would expect this to return 72. So our sales are multiplicative, meaning a 20% sale and a 10% sale ends up being a 28% total sale. So this is what I'm expecting, the 72% of 20% off of 10% of my $100 item, and tax should be 0. I don't have any tax. I didn't add a tax to this, so it's just my sales. Sales should be multiplicative. Taxes should be additive, though. If I have a 4% tax and a 5% tax, that should be a total of 9% tax. You don't get taxed on tax. There's no such thing as compound tax, thankfully. But there is compound sales. For example, if I have an item that's 50% off and somebody comes in with a 60% off coupon, I don't pay them 10% to buy that item. So those are multiplicative. So make sure you have the differences working right. The other thing is if I add a 10% tax to this item, I'm paying $7.20 in tax. I'm not paying tax on the base price. I'm paying tax on the sale price. So there's a few pitfalls that I wanted to get out there. And have a great week. I'll see you the following Monday.